from left to right, did you see that, we read the data and split it, mapping to multiple nodes, and then do sorting, shuffling, and then aggregate research, reduce, the filtering, aggregation, summarizing, transforming those, reduce, and then final results. So workflow used to be from left to right, sequential. So that's so-called batch processing. MapReduce, is it popular now? No, or other, mostly no. They maybe not, yeah, they probably not so popular to other, majority of people. Behind, there are many applications who are relying on that platform, especially batch processing, bank, or the earlier systems. So now we know that pretty much Spark has replaced or it's a lot more popular platform, right? What would be the reason? By the way, it says fast. So fast, nickname for that is a fast, interactive, language integrated cluster computing. One thing is not so new is a cluster computing, right? So MapReduce was a parallel programming platform for cluster computing. Cluster computing means clusters of computers are used for a single task, right? If instruction lab, there are multiple laptops, PCs, dedicated for one user sitting in front of it, that we don't call it as a cluster computing. Cluster computing means that, we, from the beginning we talked, right? Clusters, more than one group of the computing nodes are used together for a collective, purpose. So cluster computing, MapReduce is a cluster computing parallel programming model or platform, right? So that's not that new. The other words are new compared to MapReduce. Fast. MapReduce was not fast enough, or this is faster. That's what it means. Interactive. This is a big thing. Previously, MapReduce, what was it? Left to right, sequential, batch processing. You just throw the word, you just wait. Even if the amazing thing, by the way, let's not really trash MapReduce too much. What are the good things about the MapReduce? Make the programming easy, and still, if you were to say some great thing, great property that MapReduce offers, what would it be? Do you remember some really, shocking or eye-opening anecdotes? So programming made easy without all the hassle, right? The key is failure, fault tolerance, not failure, fault tolerance. So this is the eye-opening thing. One time, 1,600 out of 1,800 machines, practically, 80%, that's the number, right? Machines, not just the 8 out of 10. 1,600 out of 1,800 failed, but it finished fine. This is a really eye-opening, amazing thing. MapReduce, prior to MapReduce, it was programming, coding, crashed, you run it again. oh, my thesis, I have to extend it for another semester or so. Now, it was very robust. So that was an amazing thing. So Spark, it inherits actually, it also has the beauty of fault tolerancy. However, unlike or compared to MapReduce, it's faster, it's interactive. What's the opposite word of interactive? We just mentioned before, starts with B. A, T, C, H, batch, right? Rather than batch, it is an interactive one and language integrated. So MapReduce now it supports more languages, but when it was introduced, it supported just one language. So MapReduce for user, it's just an API class that's available extended. What was the language it supported? Java. It supported Java only at that time, and people started to use Python more popularly, and then C++. Whenever somebody says Java, what about C++, right? So the Spark, they decided to support more language, but that means it's just a more laborious work supporting in the compilation. So that's what language integrated means, and it's not batch, interactive in fact. But just by this word, so it's always important for us rather than, so cloud computing, it's always evolving scene, evolving environment. Whatever you're gonna learn, it's gonna be outdated soon. So the point is not that learning the snapshot of the most popular platform. That's not the case. But really looking at how people tackle the problem and then come up with a new one. And be able to appreciate the new one, still be able to criticize it, so that what might be needed later as an improvement. So the MapReduce was batch. This is an interactive, right? What are the applications that you find these days more interactive? If you were doing cluster computing development, what kind of thing are you gonna do? Big buzzword, AI, right? Then what about the AI, the program? How does it work? You have a machine learning, the auto AI. So, there is layers, the multi-layers, more than 2 deep learning, right? And then it has a weight, a lot of computation. It feeds back to the earlier, layer, and it does iterate. Backpropagation, not just 2 layer, now
multiple layers. Yes.
The point there is a feedback and iterative process. MapReduce workflow will not fit in that kind of, workflow. So that's how you have to appreciate it. How do they find the problem, find the limitation? Well, look at the now current or future applications. Their workflow is different from what MapReduce supports. So that's it. All of these people, you probably recognize them, some of them, especially the first and last ones. Scott Schenker, Jonas Burkhardt, these are the people you're going to see again in the software-defined networking. And it was the one who I was a student back then, and then Professor became Professor Stanford. So here I have some histories when the Spark was, Spark became some summit, a workshop itself. So started from Google MapReduce. So Google File System published in 2003, means the work was done in 2002 or so. MapReduce right after 2004 published, but they have done it internally in 2002. Became paper 2004. Yahoo used to have a good intentions, so they not only do the Hadoop, they had Hadoop Summit, and then Spark paper was published in 2010, meaning work was done earlier. The Spark became Apache project and the top platform. What this shows is that not just sequence, it's really about how soon it becomes the international, it makes the international impact. Later, there has been so many high peak and so many things you would see. The point, so this is a talk for Spark. So the reason is that MapReduce over here, it was a generalized batch processing platform, but soon, within a few years, there has been a lot of specialized systems, interactive, screening, graph, etc. So from one to so many. That means that this one didn't really work for this kind of applications. So this is a Spark Summit talk from Meta. So let's take a look at the MapReduce. It was amazing, parallel programming platform, easy for a programmer, no need to do all the synchronization of threads and so on. Fault tolerancy is wonderful. However, still it's not really easy enough. Maybe you can do something better than that. Another thing is that the original purpose of batch processing didn't fit a lot of these cases. That was foreseen in 2009, 2010, early vision, right? So they have done a paper. The title was this: Spark Cluster Computing with Working Sets. So something about the working set, and then the resilient to distributed data set, fault tolerance abstraction for in-memory cluster computing. These are the papers published for the same group, Spark. So the keyword you see working set. But what else? Fault tolerance. So it inherits the MapReduce, and then in-memory cluster computing. You see, the in-memory stuff you have seen now multiple times. Facebook, Haystack, right? Google file system, master server, right? In-memory has become really important, the speed up technique. The things that used to be in storage, and then just let the operating system bring it out, run it whenever it needs the processing, one page at a time, rather than that, have all these meta or working set keys in memory. So here's the Spark in short. So MapReduce for really generalized batch, and then you saw a lot of Dromel and so other systems for special systems. Now they do generalization again, but for new applications. The new applications, particularly that makes the data sharing easy, and that stands for. Acyclic graph. So, having this goal allows a new approach for efficient processing. About the code size, open source it can be easily big. What they are saying is that compared to Hadoop, MapReduce, and other related programming platform, how it's a lot, but well, in comparison, it's really compact. If you say the libraries. So if you're doing any interview, okay, what's the biggest line of the code you have done? Couple of 100 lines. That's you have to put yourself in a perspective. So here, the key points about Spark. It handles interactive one, but it does not mean it cannot handle batch. So it's more generalized. Right? Yeah. It handles batch or interactive and real-time applications within a single framework. So previously, again, we see this. MapReduce generalized batch, and then there are so many different platforms for different purposes. By the way, this also tells you your goal should be never conquering all of those, right? You will never master it, or there will be a new one constantly. The always is a purpose driven. Whenever you have a special project at hand, you make a informed decision. And then you should be able to compare them. Anyway, there has been a lot of specialized platforms, and Spark is trying to generalize them in a single platform. So not just batch, but also interactive and other streaming applications and so on. Native integration with not only Java, but also Python and also Scala. Anything you can tell about Scala language? What type of language is that? Python, you could say it's interpretive. One keyword for Scala is functional language. Okay? So functional language is the function recursively being defined, list, is a. By the way, in computer science, there has been the operating system used to be really big, and then not so much, and then with all the mobile devices, operating system again is a big thing. Programming language. There has been so many different programming languages before in older times. How many languages you know must be something proud to say that. We know that that's never the case. Knowing a couple, one or more language. Whatever, mastery level. But anyway, programming language itself is a sub-area of computer science. Used to be really big, and then C, C++, Java, and then not much languages. And then these days, with mobile and Google, all the big companies, they have their own programming languages, Go and so on, right? So the programming language is also really evolving, very improved. The active field in Scala is one of the functional programming languages. Functional programming language is also getting the renewed attention in recent years. Then programming at a higher level abstraction. That's what we have seen before. Mapper, reducer, right? So that's that MapReduce really the enabled higher level of abstraction, making the programming easy, and Spark does that too. Okay? More general than MapReduce. So the Spark uses memory for speed up, as you will see, working set, right? The more you put it in the memory, the faster the processing will be. At least the Spark does it. Programmer doesn't have to really pay attention to much of it. But you can also use main memory, in a not like yes or no. There are multiple levels. So what it shows is that you can have you can set how much of the data will be cached in the memory. So like not fully versus even disabled, it's all possible. And what it shows is that if you put more data in the memory working set hash, then iteration time, in other words, processing will be faster. So you can adjust this use of memory. So at Singapore, it's generalizing MapReduce to better support the iterative and interactive applications as well as the batch processing. So iterative algorithms, machine learning graphs, interactive algorithms, maybe user does involve, you want to eliminate some part of data or provide input to the data. So this kind of thing can be also rerunning and take advantage of the speed levels. Making programming easier. Functional programming language Scholar is part of the support as well. In interactive use, using Stellar interpreter, that's also on top. So this is what we had before for MapReduce, which is a acyclic data flow, in other words, sequential data flow. Nowadays, the great thing about MapReduce is that failure was handled gracefully. 1600 out of 1800 failures still finished. What was the last word? Finished. Fine. Fine. Right. That's a. You should be surprised. Right. So that. So I told you use of in-memory. What should be in memory? Of course, in the parallel programming platform, data needs to be processed. Among those data, hot data, data typical locality, temporal spatial locality. The one that is red, if this data is red, the next one is likely to be red again soon. Spatial locality. Temporal locality, if it's red now, if it's accessed now, maybe in the near future. So those things can be in a so-called working set, put it in a main memory, and make it easily or more efficient to reuse. So that's what Spark allows. And the key, the term that Spark uses for this is called RDD, Resilient Distributed Data Set. So it will be in a format and put it in a supports wide range of applications. So they have a definition for the RDD. So this is a parallel accessing. It's easier. So it's mostly immutable objects, and data can be partitioned. And then they have special APIs that offers for data processing. Map filter group by enjoy this kind of database data the operations. Again, it's cached for efficient reuse and put it in the main memory for the faster. And the RDB so really this database community, database knowledge and computing knowledge work together. They enable these kind of insights. So this is just to show some the machine learning related operations. If you want to find the line that separates these two set of keys, the iteratively, what's the line that reduces, minimize the error between two groups. So eventually, it's iteratively finds the line. Then you will have to have the code like this, but behind it, data access. So you have to do computation. What's the error? What's the distance between all of these? You keep doing the summation of those. So the rereading this data is all in memory. You don't have to read it. Or without this platform, without users, developers, anything doing special, it would be in memory. Whenever you read it, oh, oops, I have to read this. It's not in memory yet. I have to read it. And then later, oh, I have to read this. It's not in memory. You have to read it. Rather than that, Spark puts that in the RDD, and it's already available. This is also, you should be really shocked, okay? So, ready to be shocked. On the x-axis is number of iterations, y-axis is time. So, regardless of with the increase of iterations, less time, that is a main thing. You see the spark is in red, very, very small. So, what is that? The more number of iterations the algorithm might have, the better gain that spark it brings, right? Big gain. This is really sublinear. This is exponential behind. So as the scale of the problem gets bigger, the benefit that spark brings, it's really wonderful. So remember, spark. What was in the title? Fast, interactive. What was the other one? Cluster computing. That's the what Spark offers. So they have done their company. So this is 40 times better than other platform of Hive that was running on top of these magnetics. Other platforms, they chase, we have this, but we can run on top of Spark. We can run on top of Spark. So then there has been some, you have to memorize that. So just in comparison, we talked about the clusters. Here I'm talking about there will be GFS or distributed file system. Part of the distributed file system would be scheduler. Resource is the one that does resource scheduling, like CPU scheduling. Again, this was also a paper coming from Google. And then on top of that, you can run Spark or MapReduce or other multiprocessor implements. The Spark also has its native scheduler. I'm going a little fast, but for those who are interested, you can take a look at the more detail of these slides. So, simple, efficient, powerful programming model for a wide range of applications, including interactive, iterative the applications. There's no question. What kind of, you can think of, like, can Spark supports the batch applications? Yes, no?
Yes.
So it's a more generalized, and it is also, it can support the interactive applications. You see that this is a more figure that shows the hierarchy, distributed file system, and then resource manager means scheduler, CPU scheduler. Resource is one of them. You might have heard of others. Kubernetes is also this open container that does that. And then Spark, MapReduce, these are the ones that run Spark. So at least they all look at these names. This is even a few, maybe a couple of years outdated, but still you see all the things are still very popular. When you hear this name, Mesos, Spark, you cannot tell exactly what it is. First thing is that you have to know, now you know a few things, right? Is that is that a programming platform model or distributed file system or not? Is that a resource scheduler, manager or not? Resource for what kind of resources? Typically it's compute resources. What kind of application is it specialized, or is it does it support? Those are the questions you should ask. later maybe I should ask you a question, asking that what question do you ask if you are running into a new, say, some platform, competing platform, and you should ask what level of platform it is, what kind of application does it support, right? How does it support? So let me ask you, so really Spark can support graph algorithm, interactive algorithm well. How? How does it do it best? We talk about it, right? RDD, being in memory.
Being in
So
memory,
you
yes.
in memory, you don't have to, iterative. Oh, oops, I need this data again. Oops, I need this. Read it again. Doesn't matter. Efficient reuse is possible. Data structure being defined, RDD, and then the efficient data query API operations supported, and all in memory. So really, really key idea. Put it in memory. It's easy to say, but it has to do all the details to support all this. Does Spark supports fault tolerance? Yes.
Yes.
Yeah. So, does it have a good thing that MapReduce used to have? Yes. Which is a fault tolerance. Right? So, out of so many things, you need to be able to ask critical questions and be able to compare and kind of they have a big picture. How does this different parts relate to each other? Right? But OSM, OAI, all these things, what are their relationships? That's important. Questions? Yes.
Like Spark is made based on the MapReduce, right?
Based on MapReduce, well, they designed the data structure API a little differently.
But it mostly
But the lower part, really lower end fault tolerance, it is based on MapReduce. You can say.
Okay, yeah, that's what I'm asking. Like, MapReduce has some of the structures and everything, most of the things, not everything, for the inside the Spark, right?
So the Spark does use a lot of features that and it's not they reuse the code. They could, I don't think so. Yeah. But they do support what MapReduce used. So in some sense, they are building higher level abstraction. Lower level system, does it fail? It has to cut it. For failure, the fault tolerance is first they have to check the failure constantly and then do something about it. And now those things are all Spark inherits. And then on the higher level, RDB definition, putting in the main memory, bigger, higher level abstraction or efficient reuse. That's did I answer your question?
Yes.
So I'm afraid we don't have a lot of time to talk about the other platforms. But I think by looking at some of the examples, how it progressed over time, whenever you are facing new platform, I believe you are better equipped now to make informed decisions for your project. So next big portion of this segment is a network virtualization. So far we have talked about the compute virtualization, the engine of cloud computing, and storage virtualization, regardless the physical location, the interface, the storage can be made available with some redundancy, for its users. In that sense, we also talked about the distributed distributed file system as well. Now, network virtualization. And we are going to also talk about SDN. SDN stands for software-defined networking. You probably have heard of these days now, software-defined X, right? Software-defined storage. This is not software-defined. I would say some of the picture frame, that's a software-defined. If I go to airport, all the destination, in older times they put really papers or plastics whenever they have a change in the schedule, destination. Nowadays it's all screen, right? The software-defined board, right? So the software-defined, there is a conference called the network softwareization. So the things that used to be in hardware, ASIC, firmware, now it's more done in software. I see that software folks, it's important for us to know how hardware characteristic is, what kind of new hardware it is, right? So hardware folks, they have to know software as well. So really understanding both sides is important. So we're going to talk about here what is network virtualization, why, and how we implement them, and then SDA. What, why, and how. So network virtualization is the process of making network resource into a software-based entity. Those are the keywords. So process of combining hardware. So because for network, there are also software and hardware. Network resource, routers, switches, right? And then the software resources, protocols. The bandwidth, all those resources are combined together and be able to have a high level of this is entire network resource. And then now let's do administration with a software. That's the idea. And the goal of network virtualization is making a virtualized network, virtual network. Not VM, VM. VM is a virtual machine meaning computer, right? So it's really centered around the compute resource. And then of course for a computer we need to have some memory, some storage, altogether, some I/O. But it's really for a machine, single machine. Here this is a single network that includes multiple nodes and links. Network, how do we depict it in a graph, in a picture? Usually we're using a graph, right? Node and links. So for any network research or thinking, you need to have a basic graph theory. What's the discrete math, discrete structure you learn basic ones, even in high school, right? What's the graph diameter? What's the simple point of failure? What's the average node in and out? The average connectivity, things like that. So we depict a network with a graph. We want to be able to make a network that has node and links, but it's not necessarily comprised of the physical resources. It's a virtual one. So this enables multi-tenancy of virtual networks on a single physical substrate network. We can have multiple virtual networks on a single resource, and each network, they are isolated from each other. Now it's all similar to ones you have seen before, right? Virtual machine. We can have multiple virtual machines on a single physical resource computer. They share the physical resource, but they are isolated. They're isolated from each other. Namespace is different. They should not interfere. Protection from each other. That's what we used to talk about it in compute virtualization. Now it's not that surprise, but just we're talking about the network. So this is really, I think the picture that shows you what virtual network is. So here's the physical network substrate resource, where there are interfaces, the routers, switches, network resource. It can be actually end system as well. Anyway, physical network resource, and then on top of that, there can be multiple virtual networks. That just, I mean, these two networks is not really, they may share some nodes together or not. So it's a really logical network, virtual network. You can find some mapping on the physical resource, but one node can be multiple nodes on a virtual network, or vice versa. And what about the links? There can be multiple links in between physically, right? So, or it can be really multi-hop, but this is a logical link. So this is a virtual network 1, virtual network 2. We said it's isolation from each other. That means that the bandwidth separation traffic, if you are sending traffic on virtual network 2, it should not be interfering with other networks. Right? So this one picture actually really explains what virtual network is. Questions? So that's what it is. What and then why? Why do we bother to have a virtual network? In other words, what are the benefits of virtual networks for network virtualization? For what purpose? Have you used a virtual network that you know of? Anyone used? Yes, VPN.
Yeah, okay.
That's a virtual network. What's that?
Virtual private network. VPN.
Virtual private network. Yeah. So that's a virtual private network. Virtual network there, right? So you use it. I mean, UMKC virtual network, right? we used to have a different kinds of virtual network. The one that we use now is called Global Protect, right? So it's really application layer. Previously we used to have an IP level internally, but this one also eventually too. So what does it do? Why do you use a virtual network?
So that we don't get into the other network and get rid.
Get into other network. You can get to the other network from without VPN.
VPN helps. This VPN helps us to protect from privacy and everything else.
When you want to access a particular
Route.
resource or machine being in other location instead of being the same domain or the same right. So it allows the access to some either application resource or physical resource. Application resource like IEEE ACM. If you want to access articles published there, unless you have an individual subscription, you need to pay per article. But university subscribes it as a part of your tuition. If you access it through the university network, they know that UMKC is a part of the subscribers, and you have a right to access it. So that's an application resource. You can access the university instruction lab, right? Remote desktop, right? So it is really the making your traffic going to the UMKC network. Here's a UMKC campus at home. Maybe UMKC, the www.umkc.edu will go here. But what you do is that that's only for that public access. But you want to access some UMKC resource only available for UMKC network with a special IP address or special network prefix. Your traffic will be pointed to the access, the gateway, and then you go to other places within UMKC. So the network traffic is actually geared to the network to access physical or application resources, right? So that's some usage as a user, regular, as a student. What about as a researcher? This can be also very helpful. Like, we want to develop a new protocol. It has to be tested. It has to be evaluated. And this protocol also, suppose somebody has tested in some test bed and we want to be able to adopt it, but we don't want to. We operators worry that it might crash the entire machine, entire system network. So maybe incrementally adopt it, right? So when we have a virtual network, we can have a protection from each other directly, and then we can actually control the scope of the network. So adopting new protocol, designing new protocol, evaluating new technique. If you have a virtual network, it will be good to be able to control the network, right? The other purpose or other benefits could be multi-tenant environment. Just like cloud computing, we support multi-tenancy for other users in the machine context, now even network context. Right? Why network context? For a company, like suppose you have a big company, have branches in East Coast, West Coast, different part of the world. You want different branches of the same company to interact with each other beyond just web, public web, and that may be a secret, the private commercial information. You want to be able to control the traffic, the not going through somewhere and so on. So for that kind of purpose, the beyond the compute resource, but network resource, multi-tenancy environment. Rather than going through the public internet, internal the resource, networking resource, storage resource, compute resource, all controlled that support different users for different applications that will be hosted. So here's an example where say different departments of a company or a school that are all interconnected together. Initially switches, and then this is a top of the rack switch, and then aggregating switch, and there can be a router as well. And different machines might be dedicated, used by different division, like business people, marketing people, developer. They are all connected together, but really the traffic doesn't have to be mixed all together. So this is an example where it shows that regardless of the physical location, depending on the usage, the payment service, production internet, testing, development, based on the usage, their traffic might be separated from each other. We do use the VLAN a lot within UMKC. VLAN for admin center, VLAN for engineering, flash and call, and maybe other students, and so the different VLANs for each schools, for example. We don't do that in cloud computing class, but in network architecture class when I teach, I also have a guest speaker, not from data center, but from network architecture team. Then good questions you could ask. How many VLANs do we have? Tell me an example of VLAN. What's the size? All those number related ones are good questions you can ask to the people who comes from the practice, from real practice, right? So you might say, what about the people, business folks? They can be all in the same room. Well, you want flexibility. Sometimes their responsibility can change, right? And you don't have to make people move around. So this different application purposes, their traffic can be separated from each other. So even this is a one physical network, virtually you might have three different networks for different applications. So virtual network, the gig application or tenants its own virtual network, with a different topology bandwidth, and an important thing is the broadcast domain. And then the administration can be different, right? So broadcast domain, any protocol that needs a broadcast. There are a lot, right?
Can you repeat the question?
Do you know any protocol that needs broadcast? TCP is not a broadcast protocol, right? But do you use the broadcast protocol? Yes, you do a lot, right? So, example, SNMP? SM?
Internet control message protocol.
Internet control messaging. ICMP. Oh, ICMP, ICMP also does the control messaging, route discovery, and so on, right? Yeah, it's and like if you want to do multicast domain, you have to do discovery. Yes, you can do that. And other examples actually, you use almost every day. DHCP. When you get into a new network, you don't know anything. Your computer doesn't know anything in terms of what IP address you could use, what is the gateway router protocol, what's the network traffics. If you go to a new coffee shop, coffee shop from home, whenever you move your network around, you get to get connected. And for that connectivity, you have to get an IP address. For you to get an IP address, you have to do a discovery. What's the IP address available? Who can give me an address? When you don't know anything, if you know, meaning that you know who to talk to, this is IP address, then you don't have to do broadcasting. But usually in network protocol, the assumption is you don't know. Really, you don't know. So what do you do when you don't know? You shout, you broadcast. Hey, I'm new. My device is new. I need to. Can anyone get me an IP address? That's all broadcast one. Also, any LAN protocol, any traffic that goes outside of the UMKC, that traffic will go to default gateway router. Any traffic within UMKC, within a LAN, you have to find out the MAC address of the other computer. To find out MAC address, there is a protocol called ARP, Address Resolution Protocol, right? You only know initially just machine name, like mymachine.se or mymachine.umkc.edu. And then you get the IP address, that translation, NS lookup. From IP address to actually the physical address, the Wi-Fi, the Ethernet MAC address translation, you have to actually do a broadcasting and then find it out. There's an ARP protocol. So both DHCP IP address scaling, both the MAC address resolution, the address resolution protocols has to run broadcast. Okay, so who do you broadcast? You don't broadcast into the whole entire world. Then the world will be so noisy with that one. So that your broadcast is limited to a LAN. If LAN is big, a lot of nodes are there. If so many nodes are doing the broadcast, the network will be crowded with those control protocol rather than actual data transmission. Therefore, that's one of the big, actually, the single most reason that they want to do limit LAN size. Okay. So the that's a broadcast domain. We also call it later collision domain too. Depending on protocol. We don't want to this Wi-Fi or shared medium, old Ethernet or bus topology or the wireless network. This is a broadcast medium. In this classroom, we have so many people. Somehow, I get the authority talking to most of the time. But suppose I'm not here. The way you do is that you just shout, and maybe somebody else shouts. Electromagnetic signal, they might collide. It's not understood, and then you have to try the random access protocol, and there are multiple types of protocol to resolve that issue. But that's all due to the broadcast domain. It's not like one-to-one, point-to-point link. Hey, you get it, and I get it. It's not like that. This is a shared medium. Everybody can use it. And then if more than two nodes try to send at the same time, then there will be a collision. This collision has to be resolved. So it's all the protocol issues. Again, so that's a broadcast domain issue, right? Therefore, network admin want to limit broadcast domain as small as possible. You can easily actually everything. Whenever I say it, anyone who is attack mindful or security minded person, anything that is to do with the broadcast, that can be a point of attack, right? You can seemingly naive the traffic can broadcast it again and again, bombardment, that sort of possible. So a little more story on that. We want to limit this domain. Virtual network, VLAN can help it. So we talked about VLAN, VPN. It's a little different. VLAN means it's LAN, meaning it's layer 2 or 3. Layer 2, right? Local area network that doesn't go through the router, right? So if virtual network is implemented in a LAN layer, we call it VLAN. VPN, it can be, typically it's a layer 3, so IP tunneling, we say that. It's a layer 3, but it can be also layer 2 or physically layer 1 or 2. And then there has been pretty active area called active networking, programmable networking. Routers do something active rather than just passively, doing what is already configured. Active networking used to be really active, and then was not so active. We used to joke that active networking is dead, not so active, right? People used to say that, and then SDN was appeared. So see. It's all the result of the work of active networking community. So really active and programmable network. You can say precursor for software-defined networking. So routers can do something, programmable stuff. At previous purpose like that. Rather than just blindly doing whatever, traffic transfer without anything maybe actively, oh, this is more priority traffic, this is a less priority traffic, this is a special condition where network is congested, I want to actively drop the packet, so the sender will be first faster aware of the presence of congestion and do something reducing its rate and so on. So the making routers do more active role, that was the intent of active or program networking, and that's again precursor of software defined networking. And then wait a minute, P2P system. P2P system, we also put it in a graph. Node, here node can be application program, BitTorrent file sharing program, and the links will be maybe P2P protocol that runs on top of TCP and so on, right? That's also network. That's not, it's an overlay, logical network. Isn't that a virtual network too? Yes, it is too. So application layer virtual network, it can do different things. So VPN, not VPN, virtual network can be implemented in which layer? Any layer. 1, 2, 3, 4, 5. Okay. This is layer 2. This is mostly layer 3, but you can actually physically port. You can use a different one. This is, you can say more of a layer 3 one, and this is a layer 5 application, but you can also certainly, be instead of the TCP UDP or above IP, you can do something different over here. So this is the defining VLANs. Sorry about that. Here's a switch, and you see Ethernet and optical switches over there. These are the ports, and you can really physically. This port is for red network. This port is for the blue network. This is a layer 1 static port base one, but still it's for LAN purpose administratively. And you can also do dynamic one based on not physical port but MAC address. So if I, they have changed it, but when I visit the Air Force Research Lab or NASA over summer, they have a visiting faculties, and security is a big concern. You have to register your MAC address to the university. I'm not sure whether you have to register your MAC address to the university. No? Probably not. It's too many. They don't do that. My laptop, university, purchased with the university, through the funding university, that all MAC address is already part of their database. So based on MAC address, they might accept or reject traffic and steer traffic to different places. They can be also so-called trunk. This port goes to different network and maybe steering network to a different one. So you can do physically trunking, and also there is the trunking that can be done with software called tagging. I have a picture of it. Trunking means that you aggregate multiple ports linked together. So what are the link layer protocols that IEEE standards? 802.11. Wi-Fi, it is 802.11. 802 is a link layer IEEE standards. 802.3 Ethernet, 802.4 token bus, 802.5 token ring. You don't hear it much, but at least Ethernet and Wi-Fi you should know, right? Ethernet 802.3, Wi-Fi 802.11. You might have heard of 11P, the vehicular network. Anyway, 802 is a link layer protocol IEEE standards, so it will have a special headers. And 802.1Q is a tagging protocol in a way that it's not entire link layer protocol, but it adds a little bit of text. That's what it means. So here's a normal Ethernet frame. By the way, Ethernet is a really simple protocol. You see, how do I know it's a simple protocol? the fields are so simple. Preamble, CRC, beginning and end, respectively, and the data. What's the next thing is that actually basically destination, source address, and data type, which is uploaded, and that's pretty much it. Right? The not much thing it does. It does no reliability, it does no connection management, it does no error recovery, anything like that. So this is a simple Internet protocol. So you see this is all the same, but this area is inserted. So additional tag is inserted, and what it has is that VLAN ID, 12-bit. So VLAN ID can be tagged with Ethernet. VLAN ID can be tagged with Wi-Fi 802. So this is an 802.1 queue that can work with either Ethernet or other 802. 12-bit, how many VLANs? 4K. Big enough or not? You think it's big? It is big. I think probably it's okay for UMKC. You know, you will hear actually about maybe 500 VLANs we use. It was a few years ago. So 4K might be okay. What do you think? If it's a big company in Bay Area, probably not. What about the data center? Okay, there's so many applications, different customers. Probably they can use some of these, but it's not really enough for all kinds of virtual network purposes. Right? So those are part of the limitations. VLAN, the well, anything there is a new thing or different thing that you have to criticize. It's your role. So these are some criticisms that are made against the VLAN. You know, if you have to do configuration manually. The admin has to do, and VLAN members on the main. And this is actually what really network admins does the most. Spend a lot of most time. VLAN automations are still. So you do have to have a good understanding about the protocol stack and LAN issues and so on to become a network administrator. LAN is the most important part for a network administrator because their focus is a network within the enterprise should be working hard. So LAN enterprise folks might be okay, but really for researchers, SDN idea came out of Stanford. The PhD student Martin Casardo. It was his dissertation. And then with his advisor and Berkeley, Scott Schenker, UNC Williams, they really made a big industrial as well as academical movement to make this idea to be percolated into practice in different fields. So people in networking research, what we used to do is that you have a new idea. If we find the problem with that's what researchers always do, find the limitation and then come up with a new one. For a compute, it's okay. For a network, it's really difficult to evaluate, to test it in a larger scale. Typically, what we used to do is using simulations, network simulator. These days, the ITS, the traffic simulator, it's also the simulators. Simulators, of course, is amazing, important, but still, it's less convincing story. There has been test bed. Before precursor of Cloud Lab, we used to have a Planet Lab. Cloud Lab more for cloud computing, but we used to have a so-called Genie there, really to be able to study and design future network. Right? So there are some, but it's all test bed. It's not really real practice. So that's a background. Do we really need a new protocol? Well, of course, researchers know that there are so many problems in protocols. However, it's internet was so ossified, so rigid, so not adaptable. They don't really adapt to new protocol. Um, the most infamous example, anyone knows? IPv6. IPv4 32-bit, IPv6, addresses the issue of the address space exhaustion. They noticed the problem in 90s, before you heard of a lot of internet. Some people born even back then, right? So the IP address is going to be exhausted. There are some groups of people constantly plotting how much address space is available now. Still, operators, researchers always, this is and then already new protocol they introduced it in the 90s, IPv6. But it's an infamous protocol example where the people doesn't use it for a long time unless really you have no option. That happened only several years ago. So that's how ossified the internet is. So many ideas, PhDs, masters, great papers, it's just buried in paper, like not really being utilized. Ossified questions, please.
So IPv6, is this was that applied during that time, or it is applied recently?
IPv6 it was introduced in 90s.
Yes.
And then people didn't really use it. And then gradually, really got exhausted all the rest, little by little. So it's an incremental adoption, but it has been really, really slow. Right?
Yeah.
Now our university, we use both.
Yeah, in my country, the network was shifting. I think they are using IPv6 in some of the companies. So that
so
time,
the ones who started late will use IPv6, right? The ones who started early, we are okay with IPv4, and still there are a lot of tweaking techniques, right?
It's an internet company. They started very much so. They're the best internet company in Bangladesh, but they adopted the IPv6.
Yeah. So now the IP address v4 is really exhausted, basically in terms of big allocation. Our university still have a v4 address, but it's finally IPv6 has its rolled in, right? But the idea is that why did they take so many years? It's so ossified. So that's one of the important background of SDN. Next time we're going to talk about the main idea, separation between data plane and control plane. This is easy to understand relatively, but still it's an amazing thought they have. Right? So hopefully you'll be able to appreciate it next class. Let me stop here for today. Next Thursday class will be the last one. So last in person. No, I shouldn't say in-person night class. But the following next Tuesday, our GA is going to have a really good hands-on session.
Next class?
So Thursday I'm gonna meet you, but that will be last one. I meet you in person this semester. Okay. So feel free to ask questions, right? When you get a chance. Okay, so let me start with today. Assignment 6 is out, and assignment 7 will be out as well. I think I'm gonna make assignment 7 as an extra. It will be really fun, but I understand that you might be busy, so that's the. Okay, so that's it for today.